Hello and welcome to this presentation, or I guess this is more of just a demonstration of sort of the first version of the particle filter for the WiiMote system that is working. So let me first just describe what this is. This is a Java program that's running right now that's taking information from a Rocket brand WiiMote sensor plugged into an Arduino Uno. That's currently that information is being taken into a Java program, and then the Java program is pretty much displaying this GUI. So the WiiMote will put out 4 different blobs, and then what we have right now is a particle filter with 100 with 100 particles, and this pink particle that's in the center is the mean location of each of the particles. So if we average each of the x positions and each of the y positions, we get the mean location of the pink particle. And essentially what happens once the particle filter starts working is that this pink particle is going to hover on top of the location of our infrared beacon. So now what I'm going to do now is I'm going to bring into view our modulated infrared beacon. So now what's going on here is essentially this beacon is going to modulate. Right now it's modulating at about 2 hertz. It's going to modulate much faster once this is, I have to optimize it a bit more, but in the final version it's going to modulate much faster than 2 hertz. In this demonstration it's going to modulate at about 2 hertz. And what you'll see is that once I bring this 2 hertz modulated signal into the view, this pink particle is going to gravitate towards that modulated IR light. And also, based upon the standard deviation of just the distribution of particles in the x direction, that's how we're determining whether or not we've located the beacon. So also, once I bring this beacon into view, this, instead of saying beacon not found, it's going to change green and it's going to say beacon found. So here comes the infrared beacon. Okay, there it is. Okay, so there's our infrared beacon. And as you can see, what we've got here, the green particles are essentially the good particles that will kind of remain around for the next generation. And the red particles are the particles which are going to essentially respawn in the next iteration of the particle filter. So as you can see, it's very good at locking on to this particle. And it's a little slow, but again, once we start modulating the infrared faster, the tracking of the beacon will be much faster. So anyway, and as you can see down here, it's kind of hard to see, but it says beacon found. So it's saying that we have located the beacon, and if I get rid of my infrared beacon, I randomly distribute the particles again, and we go back to saying beacon not found. So now, let me go ahead. I'm going to bring my beacon back in. So I've located the beacon, and actually, one second, I forgot to plug in my DC light source. Okay, so I've got my DC light source plugged in. Here's my infrared beacon, so we have located our infrared beacon, and now I'm going to bring a DC interference source into view. And as you can see, the particle filter is very good at pretty much completely ignoring this source of DC interference. So even, I can move the source of DC interference around. So as you can see, I'm kind of moving it around, move it up, move it down, move it pretty close to my infrared beacon, and still the particle filter is very good at kind of rejecting that DC interference. So even here I'm going to try to flicker my DC interference a little bit. So there, I'm flickering it, and as you can see, the particle filter is still pretty good at rejecting that source of DC interference. This is, I'm having problems right now. I'm having a little bit of problems with just the contacts on this beacon. Okay, there we go. So now the contacts on my simulation beacon are a little iffy, but anyway. So anyway, as you can see, we're very good at rejecting DC interference. Maybe I'll make a future video. I haven't tested it yet with like 3 sources of DC interference, but I have simulated this same exact algorithm with 3 sources of DC interference, and the results have been similar. The one situation which doesn't have the greatest performance is if the source of DC interference gets too close to the beacon. What happens is this kind of switching of places behavior happens. And the estimation isn't terrible, but it's not as good as it kind of is if... actually, that's not so bad. But anyway, this is... like the position estimation isn't great when the 2 particles kind of get too close where they sort of alternate centroids with each other. But in every other situation, this seems to work pretty well. So anyway, hopefully, I'll make another video where I explain kind of what's going on in this particle filter and how exactly the particle filter works. So anyway, thanks so much for watching, and I'll see you in a future video. Thanks for watching. Bye.